Kumar, welcome back to my channel. And today we are going to talk about the most important and dangerous and frequently discussed topics in computer science and cybersecurity, which is buffer overflow, a vulnerability that looks very small at first but has power to complete break a system if exploited completely. And also the buffer is a temporary storage area in memory that is used to hold data while it is being processed. When you see the project in take that such as user input, file data or network packets, the every buffer is created with a fixed size, meaning it can store only a limited amount of data. But the problem begins when a program does not check how much data is being written into this buffer. A buffer overflow occurs when more data is written into a buffer than it can hold. Instead, it spills over into adjacent memory locations, overwriting important information such as variables, control data, or even function return addresses. And this is where the real danger begins. Buffer overflow vulnerabilities mostly occur due to the poor programming practice, especially in low-level languages such as C and C++, where the programmer had direct access to memory but the language itself does not automatically check boundaries. So if the programmer forgets to validate input length so that there it will be uses unsafe functions like gets, string copy or scanf without size limit, the program becomes vulnerable. To understand the buffer overflow actually works internally, we need to understand how memory is organized in running system, where memory is divided into segments such as code segment, data segment, heap and stack, and buffer overflow attacks usually target either the stack or heap. In a stack-based buffer overflow, the buffer is stored inside a function on the stack along with local variables and return address. And if an attacker provides carefully crafted input that exceeds the buffer size, the extra data can override the return address, which tells the program where to go after the function finishes. And by overwriting the return address, an attacker can redirect program execution to malicious code, often called as shellcode, which can give the attacker complete control over the system. Heap-based buffer is used for the send malicious input over a network and take control of system without any physical access. Historically, buffer overflow vulnerabilities have been responsible for some of the most devastating cyber attacks, such as Morris worm, Code and Redworm, and SQL Slammer, which spread rapidly across the internet by exploiting buffer overflow bugs in widely used in software, bringing down servers and networks and even entire regions of the internet even in modern times. Buffer overflow related issues continue to appear, sometimes in different forms like buffer overread and vulnerabilities which can leak sensitive information such as password and encryption keys and the personal data from memory. The impact of a buffer overflow attack can range from single program crashes to complete compromised data, and also servers and IoT devices. Despite being a decades old vulnerability, buffer overflow still exists today because legacy code is still in use. Performance critical applications still rely on low level languages, and not all developers strictly follow secure coding practices. To prevent buffer overflow attack, developers must validate all inputs and ensure proper bounds checking, and also avoid the unsafe functions and prefer safer alternatives, and multiple layers of defense such as stack canaries which detects stack corruption, address space layout randomization which makes memory address unpredictable, and data execution prevention which prevents the execution of code from data regions of memory. In addition, static and dynamic analysis tools are used to detect buffer overflow vulnerabilities during development and testing, while runtime monitoring and sandboxing help limit damage even if attack occurs. From an educational ethical hacking perspective, buffer overflow is taught not to encourage illegal hacking, but to help developers and security professionals understand how vulnerabilities occur and